Okay, this is Gauss's law on coaxial cables, part two. My batteries ran out when I did this the first time, so there might be a little repeating here, um, which is, I apologize for, but I can't quite remember where it broke off. So, I'm pretty sure that I'm okay with this. Okay, so here goes. I want to just show you something then. When we found the electric fields of these various regions by just putting Gaussian surfaces in the right spots. But a lot of times they will also ask you what the linear charge density will be on the inner surface. So they'll ask what is the linear charge density on the inside surface of the hollow shell. So for this hollow shell, what is the inside linear density, charge per length? And then they'll also ask you what's the outer one. Okay, well, this is how you reason out what the inner one has to be. I know the field in here is zero. The electric field is zero. So therefore, if I put a Gaussian surface in here, think of a cylindrical Gaussian surface right here. If the E is zero, right there, inside, then the total flux through this Gaussian surface has to be zero. So if I do the total flux through that Gaussian surface, through that cylinder inside there, if E is zero, then the whole thing is zero. But that means that the charge enclosed by the Gaussian surface is also zero, because this is one way to find flux. Here's the other way. And if this is equal to zero, then that means that this also must equal zero. So the total charge is zero. Now, if there's positive lambda here, charge per length, then there must be negative lambda on this wall right here. And they should equal, they should match, perfectly match. And so lambda inner has to equal negative lambda. I guess if we said this was lambda naught, it would equal negative lambda naught. Okay, now the outer, in order for there to be no net charge on this, we said there was no net charge on this outer surface. That means that the outer is going to have to be equal to lambda naught. See how when you add the inner and the outer, you get the net charge? So Q net is the inner and the outer. That's lambda net, the net charge density. And so if this is zero and the inner is negative lambda naught, then the outer must be equal to positive lambda naught. Okay, let's try another one of these. Let's change it up a little bit. With this coaxial cable, it's got a inner radius. This is actually kind of a thicker wire. It's got an inner radius A. This is metal. This is outer radius. The inside radius of the outer shell is B, and the outside radius of the outer shell is C. So as you look down there, you have three radiuses A, three radii rather, A, B, and C. Radius, yeah. All right, so let's take a look. First of all, if I wanted to get the electric fields, let's just say that the electric field in this metal has to be zero, and the electric field in that metal has to be zero. And the linear charge density of this inner wire is lambda naught, and the net charge density for the outer one is negative lambda naught. Okay, so what that means then is that if I have an electric field here, but if I were to put a Gaussian surface here, the total charge enclosed by that, since this has a positive lambda naught and that has a negative lambda naught, the total charge enclosed in that Gaussian surface is 0. So Q enclosed over epsilon naught, 0 times epsilon naught, is equal to E dot dA. Let me write that a different way. It would be if this has a height h, then what I'm saying is if you go lambda naught times h plus negative lambda naught times h for the outer one, all over epsilon naught. See how that adds up to 0? That equals E dot dA, the integral, the closed surface integral of E dot dA. Well, if that's 0, then the electric field outside is 0. Let me also say that's actually the point of coaxial cables, is that there's another bigger point than this, but that will show up in magnetism. But if it does have a charge, if you charge the inner surface one lambda and the other the opposite lambda, the exact opposite, it won't have a net charge outside, a net field outside. Okay, so let me just show you then what we can expect for the inner radius and the lambda for the inside and the lambda for the outside. The lambda for the inside, if I put a Gaussian surface here, there can't be any flux through this Gaussian surface because there's no field in the metal. So there can't be any flux. So the net charge enclosed has to be equal to 0. So that means that the inner surface, the surface on the inside of this cylinder, that surface, that has to equal negative lambda naught. So how do you get a net lambda? Net lambda equals lambda inner plus lambda outer. And so we're told that the inner, or the net charge on here, on this whole thing, is negative lambda naught. That has to equal lambda inner, which is negative lambda naught, plus lambda outer. So you see what lambda is on the outside? It looks like lambda on the outside, the charge per length, how much charge you have for a given length, has to equal 0. All right. Good luck.